Let's go now to 49. G of x is equal to 4/3 e to the x minus 1 plus 1. Okay. What I want to do is grasp something to the x or to the negative x. So here we see we have e to the positive x. Okay. And then I'll change it by doing the minus 1 and then doing times 4/3 and then doing plus 1. Okay. So we're just graphing e to the x. We should get familiar with it by now. This is 0, 1, 1, e. E is 2.718, so it's something like that. 1, e. And then negative 1, 1 over e, that's something right in there. Negative 1, 1 over e. All right, and up, like that, exponential growth. Now, what do we do next? So x minus 1, what does this minus 1 do? It's being subtracted directly from x. It's up here in the exponent with x. So it's going to be a horizontal shift, a shift to the right 1. Remember, subtraction by 1 means to the right 1. So all these points get moved to the right 1. Okay, here's this one, and this one. Okay, so here's the new updated version, the 2.0. Next, what happens? It's going to get multiplied by 4/3. What's multiplying by 4/3? Well, 4/3 is a number that's bigger than 1. It's more than 3/3. It's more than 1. So it's going to stretch it out. It's going to stretch it vertically. It's not going to move it. It's not going to shift it up. It's going to stretch it out vertically. It's going to make every point 4/3 higher than it was. 1 1/3 higher. Okay? Or 1 1/3 as high. So let's take 4/3 and we'll multiply it by e to the x, or e to the 1, I guess. So we're going to move this point up. We're going to shift it or stretch it up. So 4/3 times e. Times e, that's 3.624, so this is 3.624, that's about right there. This is going to be 4/3, this is just 1 times, or actually right here, 1 times 4/3, that's not hard, that's just 4/3, so 4/3 is right there. And here is 1 over e, so 4/3 times 1 over e. That's going to be 0.491 right here. So 0.491, still less than a half. Okay, so here's version 3.0. And the last thing that happens is plus 1. That means shift it up 1. If you're going to shift everything up 1, make sure to shift your asymptote up 1. And then shift all the points up 1. So here's our point right here, a little less than a half. It's going to go up to here, and I'll mark it with an X. These are our final spots, final points. This guy right here is going to move up 1. This guy right here is going to move up 1 to about right there. So the final version like that. Okay, just a few graphing examples there. All right, let's do number 57. 57 has to do with that continuously compounded interest we were talking about. Interest that's compounded every smallest possible sliver of a second that you can imagine. Okay, so it says you deposit $2,000. $2,000. That's a piece of information. Well, what do you suppose that piece of information is? You invest $2,000, well, that's probably going to be P, the initial amount, the principal. In an account that pays 4%, so 4%, that's probably going to be the rate of interest, R. See, 4% annual interest compounded continuously. Compounded continuously tells us that we're going to use this formula. PERT. People call it PERT all the time. If you say PERT in a room full of financiers, they will not look at you funny. They'll know what you're talking about. So what is the balance after 5 years, they want to know. Okay, so let's see. The amount after so many years, some period of time, is equal to the principal. The principal in this case we said was $2,000. And that's times E, okay, that number E that we learned about, to the R, okay, R is 0.04 times T. What's T? It says after 5 years, right there in the problem. So now we're just going to plug this into the calculator. 2,000 times E, second, then ln, that's E, to the 0.04 times 5. After 5 years, how much money do you have? $2,442.81. All right. We might as well do 58. It's a similar problem. We'll just get to see more of this. You deposit $800 in an account that pays 2.65% annual interest. So $800. That's the principal. 2.65% interest. Well, that's rate. That's the rate of interest. And let's see, they want us to know, or to find out, after 12 and a half years. 12 and a half years, that's time. And we're going to use this formula right here. So A is equal to the principal, which is $800, times E to the RT. R is 0.0265. We need to put it in decimal form. We're going to multiply this by 12.5. 800 times E to the 0.0265 times 12.5. We're going to raise it to that power. And that is $1,114.17. Okay. So the moral of the story is have more money and you'll make more money. You waited 12 and a half years at a smaller interest and you invested $800 and you don't have near as much money as having 4% interest. So yeah, if you have more money, you can make more money. That's the moral of that story, I guess. That'll do it for 7.3, functions involving E. We'll use E more in the future, but that'll be it for now. Thanks for watching.